Hello everyone. So today we'll be discussing this topic from pole placement with the help of an example. As you all know, this is a very basic topic from control systems. So what is the purpose of these kind of questions? It is always that you are given a system, you're given a desired system, and you're given certain desired poles, right? So this system has some poles, let's say S1, S2, S3, and you will be given some desired poles, let's say D1, D2, D3. So you need to apply some control law so that you are able to change and get these desired poles, right? So you need to tell me that what that law is. So basically the idea is something like this, that I'll just cover the theory a bit first. So it is like this, that in this equation, let's say x y equal to x plus bu. So it is governed by the states and also by the input, and the output equation is y equal to cx plus du. So now if I want to control the system, right? So what can I do? I can take like, see, whenever I need some control over the system, the first thing I can do is I can apply some feedback, right? So let's see how do we do that. So what we do is that now my input u is not there's just the input itself, right? Now it becomes something of this form. My u is now equal to minus kx plus r. So what was the point of doing this? So what I did is that this x is the state of the system, right? So I applied a negative feedback. I applied a negative feedback and added that to a reference, right? So now my u is not just u. I will be able to control this because I have this k. So the point is, if my x, if the change in state of the system, if my x goes very high, then my k, like basically this minus k, this negative feedback, will help to bring the value of u down, right? And if my x is small, then though we don't have a problem. Okay, and what's the purpose of this r? This r is a reference signal, right? It's a reference input. So this ensures that when my uh, state, that this whole term u equal to minus kx plus r, when this minus kx is 0, so this r ensures that my u does not directly go to 0, right? It stays at some reference, right? Okay, so now I'll just show you a problem, and maybe that will make the understanding better. So what I have is a matrix, my A matrix. So this looks like this. It's a 3 cross 3 matrix, uh, 0 minus 3 minus 4. Okay, so can someone tell me that what are the poles of this particular system? Like if it is defined by x bar equal to x plus bu. So as we all know, the poles of this will be the eigenvalues of this matrix, right? Okay, so now do I need to figure out the eigenvalues? How can I figure out the eigenvalues? uh, let's try doing that. There will be minus lambda 1 0 0 minus lambda 1 0 minus 3 minus 4 minus lambda, right? Okay, so now this is minus lambda, and lambda square plus 4 lambda uh, plus 3 minus 1, and these both go to 0, right? So basically this thing I need to set to 0. So basically it is lambda into lambda square plus 4 lambda plus 3 equal to 0. So that means one pole that I get is at 0, and this if you factorize you will get 1, you will get minus 1, and you will get minus 3. So that means these are the poles of the system: 0, minus 1, and minus 3. Yes, always the poles are the eigenvalues of A, right? Okay, so if now these are the poles, Now in the question it said that my desired poles are at lambda equal to -2 and -1 plus minus j. Okay, so now look at one thing. When I used this control law, minus kx plus r, so what changed? This equation changed, right? This equation that I had previously just changed. So now there's a new value of u. So if you just see, if I plug in the value of u, this is what I get, right? And this becomes a minus bk into x plus br. So that means now my A matrix has changed to a minus bk, right? And see, these are my desired poles that are given. So uh, see, the method of solving such questions is something like this, that at first you need to figure out a minus bk, right? You need to figure out this matrix. So a, I think we all have, it is something like this: 0 1 0 0 0 1 0 minus 3 minus 4. Okay, so now how do I figure out bk? So this is how my b will look, right? And k will be k1 k2 k3, right? Okay, so if I have this, after multiplying this, how will you do that? So like this row will get multiplied with this. So let me do that separately. Let me just show you once by evaluating bk, because we have some space issue. So first this row you will multiply with this, so all of that just becomes 0. And okay, so first of all, there's a 3 cross 1 matrix, there's a 1 cross 3, so your output will be simply a 3 cross 3 matrix. Okay, so now again, with this row I'll multiply all of them, so it will be 0 0 0, and then with this, if I multiply, it will be k1 k2 and k3, right? So that is my bk. What do I need to do? I need to do a minus bk. So how is my a minus bk going to look? So for these 6 terms there's no effect, so let me just copy them directly. This will be 0, okay, or let me write it here. There will be 0 1 0 0 0 1. Okay, and then there are a few changes here. So this will become minus k1, this will become minus 3 minus k2, and this will become minus 4 minus k3, right? That is correct, right? Yeah. So now what I need to do, I need to find out the characteristic equation of this particular matrix. So what is the characteristic equation? How will I find that? Simply be determinant of lambda I a minus bk equal to 0 is what you need to set. And if you do that, this simply becomes something like point is, this thing becomes minus lambda minus lambda minus lambda, right? Okay, so the characteristic equation, if I try to find, this will be minus lambda into lambda plus k3 plus 4 plus 3 plus k2 minus 1 into, this will just be minus k1, right? So if you just perform the calculations, you will get the characteristic equation as something like this: lambda cube plus 4 plus k3 lambda square plus 3 plus k2 lambda plus k1 equal to 0. So this is the characteristic equation I received after applying the control law. And what was the desired characteristic equation? The desired characteristic equation, how can I find? This was one pole, this was one desired pole, and the other desired pole was this. How do I find the characteristic equation? Pretty simple. So these three are my roots, So I just need to figure out an equation which has these three as roots. So can I write it in this form? Lambda plus 2 multiplied by, okay, now what will be this? See, my sum of roots is going to be minus 2, my sum is going to be minus 2, my product of roots is going to be minus 1 square minus of j1 square, right? Yeah, so minus 1 square minus then j1 square, so that will be 0. Oh, sorry, no, no. That will be 2. The product will be 2 now because it is like this. So you are basically doing minus 1 square minus of j square, which is basically 2. Okay, so that means my product of roots is 2 and my sum of roots is minus 2. So then my equation from here becomes this, and if you do the calculation you will get your desired equation as lambda cube plus 4 lambda square plus 6 lambda plus 4 equal to 0. So this is my desired equation. This is my equation which I got after the control law. So what I need to do is just equate both of these. So if I equate, you'll observe that there's no change in lambda cube, but my k3 plus 4 will become equal to 4. So therefore my k3 is 0. Okay, then 6, and here it is 3 plus k2. So my k2 will also become 3, and last is I think k1. So my k1 will be 4, right? My k1 will be 4. So now I have the state feedback gain matrix, right? This is the feedback gain matrix. So it looks like this: k1, k2 and k3. So this is 4, 3, 0. Okay, so I hope you understood how to solve such problems. Thank you.